Scientists call conditions in space that affect humans and our technology space weather. It's driven mostly by the sun. Space weather includes the solar wind, as well as solar flares, coronal mass ejections, and geomagnetic storms. We're learning how to forecast space weather. To help, we have more than 20 satellites dedicated to studying the sun. But the most useful tool so far is on the sun itself. That tool is sunspots. Solar storms often start near sunspots, and solar storms affect space weather. Sunspots go through a cycle every 11 years, where their number rises and falls. During solar minimum, there aren't many sunspots. Those that appear don't last very long, and solar storms are pretty rare. Solar maximum is a very different story. There can be as many as 100 sunspots on the sun at any given time, and they last for several weeks. Sometimes there are several solar storms per day. So why do sunspots appear? The sun has a large, powerful magnetic field. It extends throughout the entire solar system. This huge magnetic field is generated deep inside the sun, bursting through the surface in long lines and loops. The sun isn't solid, so areas rotate at different speeds, which twists and tangles the magnetic field lines. Sunspots form where the twisted lines emerge from the photosphere. Exceptionally strong magnetic activity keeps the plasma in these areas cooler, which is why sunspots appear dark. Strong magnetic energy around sunspots can drive solar storms. A solar flare like this one is a perfect example. A flare occurs when tangled magnetic field lines suddenly snap and reconnect. This releases a burst of electromagnetic radiation and energized particles, or plasma. Only the largest flares have any impact on the Earth. We're much too far away for the intense heat of a flare to ever reach us. Most of the problems that flares cause are related to technology. The particles and electromagnetic radiation from large flares can cause radiation storms in Earth's outer atmosphere. This might disrupt communication signals on Earth, anywhere from a few minutes to a few hours. Everything from TV signals to GPS, and even cell phones can be affected. Another type of solar storm is a coronal mass ejection, or CME. CMEs are more dangerous. Unlike flares, CMEs can affect technology on the ground. A CME is a bubble of plasma and magnetic field lines launched from the sun's atmosphere. They often start over clusters of sunspots. A single CME can contain billions of tons of material that smashes into anything in its path. The plasma in a coronal mass ejection is especially dangerous for spacecraft outside of Earth's protective magnetic field. Plasma is a superhot, electrically charged gas. It can damage a satellite's onboard electronics, causing it to fail. Many times, the magnetic field in a CME will be repelled by Earth's magnetic field, similar to putting the north poles of two magnets together. But sometimes the two magnetic fields are attracted to each other. The result is a geomagnetic storm. Earth's magnetic field gets peeled back like an onion, and particles from the sun can reach lower into our atmosphere. This is what causes the aurorae, the northern or southern lights. A geomagnetic storm can also create ground-induced current. This is an electrical charge that travels through large conductors. Things like cars, airplanes, and even trains are safe, but power lines and water pipes aren't. Current traveling along pipes can weaken or even break them. Broken pipes might mean people have to go without water. And even though power lines are made to carry electricity, adding extra current is dangerous. Things like electrical transformers can break down. If that happens, it can take months to replace a single transformer. Parts of the power grid could be shut down. That means no refrigeration for food and medicine, no gas pumps or hospitals. Even running water relies on electricity. A CME might not physically harm you, but think about all the things you use every day that need electricity. CMEs aren't rare, especially during solar maximum, but they're only dangerous if they're aimed at Earth, which is rare. The last time a supersized CME hit Earth, the northern lights reached farther south than Florida. The telegraph system, which was the highest technology of the day, was disabled worldwide. Back in 1859, the effects were minor, but something that size hitting us today would be catastrophic. For most of human history, space weather simply wasn't a problem. It's ironic that the technology that allows us to study space weather makes us more vulnerable to it.